a new kind of barrage. Picture yourself as a German soldier on the Western Front in late 19th. Dawn is just breaking, and the French countryside is cloaked in a heavy mist. For a brief moment, the front feels unnervingly quiet. Too quiet. Then, in an instant, the silence shatters. The ground convulses, the air burns, and hundreds of shells slam into your position at the exact same second. There's no warning whistle, no ranging fire to give you time to dive for cover. Just devastation, total and complete, arriving with mathematical precision. This was no ordinary artillery barrage. What you've just faced is the American time-on-target technique, an innovation that turns scattered gun batteries into synchronized instruments of destruction. Instead of firing sequentially and adjusting aim through observation, American artillery units had mastered the art of coordinating fire so that every round from dozens of batteries spread across miles of terrain struck the target simultaneously. The effect was overwhelming. Within a single heartbeat, defensive positions were obliterated, troops cut down before they could react, and morale shattered. Veterans of the Eastern Front, who had grown accustomed to the slow buildup of Soviet artillery fire, were caught off guard. Against the US approach, there was no warning and no chance to prepare. This innovation didn't emerge overnight. It was the product of years of quiet preparation back in the United States, where officers at the Field Artillery School in Fort Sill, Oklahoma, were rethinking the very nature of firepower. Led by visionaries like Carlos Brewer, they asked a deceptively simple question: how can we make every gun in an army fire as if it were a single weapon? The answer would transform artillery from a blunt instrument of destruction into a weapon of surgical precision, one that would shape the course of the war. What happened on those misty mornings of 1944 wasn't just the shelling of enemy positions, it was the sound of modern warfare arriving. A thunderous signal that the United States had combined mathematics, logistics, and technology into something far deadlier than Germany had ever encountered: the seeds of a revolution. To understand how American artillery reached this point, we must look back to the years following World War I. The conflict had demonstrated the raw power of artillery, but also its limitations. Guns were accurate and deadly, but coordinating mass fire across large areas remained crude and imprecise. Barrages were often more luck than science, with gunners relying on observers to correct shots by trial and error. The U.S. Army recognized this weakness early. After the war, instead of simply relying on foreign designs, American officers began searching for a new way forward. They had already chosen to adopt the French 75mm gun over the domestically produced M1902 3-inch gun, drawn by its accuracy, higher rate of fire, and modern recoil system. But while the gun itself was impressive, it didn't solve the larger problem: how to make multiple batteries act as one. At Fort Sill, Oklahoma, the Field Artillery School became the birthplace of this revolution. Under Carlos Brewer, instructors abandoned outdated methods of aiming fire at visible landmarks or adjusting shots through sheer repetition. Instead, they introduced the concept of the Fire Direction Center. This system used surveyed gun positions and standardized firing charts, enabling commanders to calculate exact firing solutions in advance. Every gun now knew its precise location on a map, with data tables accounting for variables such as altitude, wind, temperature, powder charge, and even barrel erosion. American artillerymen could solve complex firing problems mathematically rather than experimentally. In practice, this meant dozens of batteries could be coordinated with stunning speed. Behind the scenes, this precision was powered by an unlikely workforce: thousands of women back in the US who used mechanical calculators and slide rules to pre-compute firing tables. These prepared solutions gave artillery officers the ability to call in accurate fire almost instantly. The result was revolutionary. American artillery no longer relied on intuition or chance. It became a system, engineered, predictable, and devastatingly efficient. By the time the US entered World War II, this approach was ready to be unleashed, setting the stage for the time-on-target technique that would terrify German troops across Normandy, the Ardennes, and beyond. Mathematics on the battlefield. By the late 1930s, American artillery had become something unique in military history. It was no longer just about having powerful guns. It was about mastering the science of firing them. At Fort Sill, artillery officers treated gunnery as a mathematical puzzle. The key was precision. Instead of pointing cannons toward landmarks and adjusting shot by shot, American batteries relied on survey data, firing tables, and exact calculations. Every battery was precisely plotted on a grid, Each gun crew knew their location down to the yard, the distance to any target, and the exact time a shell would take to reach it. Nothing was left to chance. Even environmental factors, air pressure, wind, humidity, and temperature, were accounted for in pre-calculated tables. These tables weren't improvised at the front. Back home, teams of women worked tirelessly in calculation centers, using mechanical calculators and slide rules to process endless variables. They produced entire libraries of firing data, covering everything from powder charges to barrel wear. When American artillerymen deployed to Europe, they carried with them this vast reservoir of pre-solved problems. This meant that fire direction centers could respond to a target request in minutes, or sometimes seconds. A forward observer might spot a German stronghold and radio in coordinates. Within moments, multiple batteries spread across miles of terrain were synchronized for a single mission. The mathematics gave American artillery an almost factory-like precision. Instead of gunners adjusting fire until they hit their mark, they simply looked up the correct data and fired. The results were devastating. What once required time and ammunition was now instantaneous. For German troops, the experience was terrifying. They had grown accustomed to artillery that announced itself with ranging shots before unleashing a full barrage. But with the US system, the first rounds they heard were already the killing blow. American artillery wasn't just powerful. It was scientific, organized, and relentless. It was war reimagined as an equation, and the solution always ended in destruction. Time on target. The true brilliance of the American system emerged in the form of the time on target technique. It was elegant in its simplicity and devastating in practice. The concept was straightforward: fire from multiple batteries so that every shell, no matter the distance traveled, struck the target at the exact same second. To make this possible, fire direction centers broadcast a countdown. Each battery, armed with pre-calculated tables, determined how long its shells would take to reach the target. Some guns fired early, others waited until the last second. But the results were identical. Every round impacted simultaneously. The effect was shattering. Instead of giving defenders precious seconds to dive into cover, the entire barrage arrived without warning. The first shell was not a warning. It was the beginning of annihilation. Studies after the war confirmed what American officers had already understood. Artillery inflicted the most casualties in the opening moments. Time on target ensured that those moments were maximized. For German troops, the psychological shock was immense. Battle-hardened infantry from the Eastern Front were used to Soviet barrages that started with spotting rounds. They instinctively waited for the gradual buildup before taking cover. Against American artillery, that instinct proved fatal. Entire positions were obliterated before soldiers had time to react. But time on target was more than a tactical trick. It represented a philosophical shift in warfare. Instead of thinking of artillery as supporting isolated units, the US Army treated every gun in a division, or even an entire corps, as part of one single weapon system. A target spotted by a lone observer could trigger dozens of batteries across vast distances to act in unison. The brilliance lay in its precision. A forward observer might call in a German bunker. Within minutes, shells from batteries 10 miles apart would strike together, as if fired by one massive cannon. No warning, no chance to hide, just overwhelming destruction delivered in perfect harmony. This was the moment when American artillery stopped being a supporting arm and became the centerpiece of modern warfare. It was the thunderclap that signaled a new era, where mathematics, organization, and industrial might fused into a weapon system unlike anything the world had seen before. Industry as a weapon. Artillery dominance was not achieved by mathematics alone. Behind every barrage lay the vast machinery of American industry. The United States had mobilized its economy on a scale the world had never witnessed, and that industrial power translated directly into battlefield supremacy. By the end of the war, American factories had produced nearly 300,000 aircraft, almost 200,000 artillery pieces, over 85,000 tanks, and millions of trucks. For artillery units in Europe, this meant one crucial advantage: they never had to conserve ammunition. German batteries often fired sparingly, counting shells as precious resources. American units, by contrast, could unleash hundreds of rounds in a single night without hesitation. The difference was staggering. In battles such as Hill 19-2 near St. Lo, U.S. infantry divisions called in repeated time-on-target strikes to keep German defenders disoriented. Some battalions fired as many as 20 coordinated missions in a single night. To the soldiers on the receiving end, it seemed like the Americans had an endless supply of steel and fire. Mobility was another product of industry. While German artillery remained heavily dependent on horses for transport, U.S. batteries rolled forward on trucks, prime movers, and half-tracks. A heavy artillery battalion could march over 160 miles in a single day, displacing rapidly to follow armored thrusts or respond to shifting battle lines. This mobility ensured that American firepower was never static. It moved with the front, always ready to support advancing infantry or tanks. For German commanders, the contrast was brutal. Every attempt to mass troops or armor risked immediate annihilation. Every movement across open ground became dangerous. Blitzkrieg tactics, which had once relied on concentrated armor for breakthrough, were blunted by the simple fact that American artillery could respond with devastating speed and volume. Industry had turned artillery into something more than a battlefield tool. It became a constant presence, shaping strategy and morale alike. For the US, production lines were as decisive as frontline trenches. For the Germans, it meant fighting an enemy that could afford to treat ammunition like water, pouring it over the battlefield until resistance simply collapsed. The technological edge. American artillery was not just about numbers, it was also about innovation. The guns themselves represented a leap forward in range, firepower, and precision. The M1A1 Long-Tom 155mm gun could send a 127-pound shell more than 13 miles. The massive 240mm howitzer fired a 360-pound projectile over 14 miles. These weapons dwarfed the capabilities of many German field pieces, delivering destruction at ranges that often kept US guns beyond effective counter-battery fire. But the most revolutionary development came with the proximity fuse, also known as the variable time or VT fuse. Introduced in late 1944, it transformed artillery into a truly devastating weapon. Unlike traditional shells that detonated on impact, VT-fused rounds exploded in the air above enemy positions. This meant shrapnel rained down in lethal patterns, far more effective against exposed infantry. For gunners, the proximity fuse simplified the art of destruction. They no longer needed to calculate complex fuses for ground bursts. The shell itself knew when to detonate, triggered by its distance from the ground. When first deployed, the effect was catastrophic. German soldiers reported that no cover seemed safe. Trenches that once shielded men from impact rounds became death traps when air bursts shredded everything above them. Initially, the fuse was kept secret, withheld from frontline use out of fear that the Germans might capture one and copy the design. But once unleashed, its effect was undeniable. German officers admitted that American artillery fire, already terrifying, had become nearly impossible to withstand. Combined with mobility and sheer volume, these technological advances cemented US dominance. A German battalion moving through a forest might suddenly be caught by VT-fused shells bursting overhead. A stronghold reinforced with bunkers could be reduced by heavy howitzers firing with mathematical precision. Even armor massing for counterattack risked being shattered before it ever reached the battlefield. Artillery had always been called the king of battle. With these innovations, the United States crowned itself the undisputed master. It wasn't just firepower. It was modern science, unleashed with industrial scale, turning every American battery into a precision instrument of destruction, breaking the German spirit. By late 1944, the US artillery system was doing more than destroying positions, it was breaking the will of German soldiers. The psychological toll was as devastating as the physical damage. A single time-on-target strike could annihilate a frontline unit before it even realized it was under fire. Survivors were left stunned, unable to trust even brief moments of silence on the battlefield. For veterans of the Eastern Front, the contrast was especially jarring. Soviet artillery was brutal, but it was predictable, firing in waves, beginning with ranging shots that gave warning. Against American fire, there was no pattern. One moment, quiet, the next, complete devastation. German infantry who had relied on instinct and experience found those instincts betrayed. Taking cover too late was often fatal. Even elite divisions suffered. The 3rd Parachute Division, deployed shortly after D-Day, endured relentless bombardment. On days when the front was relatively quiet, the division still lost around 100 men killed and several hundred wounded, simply from constant artillery harassment. Before they even faced a full-scale American attack, they were already crippled. This steady attrition reshaped German strategy. Commanders who once dreamed of counterattacks and armored thrusts now spent their days calculating how to minimize losses from inevitable barrages. Troops were dispersed, movements restricted to night, and any concentration of force was avoided. Blitzkrieg, the very doctrine that had carried Germany across Europe, was effectively dead. The constant threat of American fire turned the Western Front into a nightmare of waiting. Soldiers never knew when the silence would end in a synchronized storm of steel. Morale crumbled. German officers spoke of fighting not against men, but against mathematics and industry, an enemy that seemed less like an army and more like a machine. For the Americans, this was precisely the point. Artillery was not just about killing the enemy, it was about denying them the ability to fight, grinding down their confidence until every decision carried the shadow of annihilation. By combining psychology with firepower, U.S. artillery reshaped the battlefield into a place where German soldiers no longer fought to win, they fought to survive. The factory of war. What made this possible was not simply battlefield brilliance, but the factory floors of America. The United States had turned warfare into a production line, where mathematics and industry worked hand in hand to deliver destruction. Every shell fired in Normandy represented not just a gun crew in France, but a chain of workers, engineers, and logistics planners back home. German commanders could not comprehend the scale. Where their batteries rationed shells, American units expended them lavishly. At times, fire missions were called in not to destroy specific targets, but simply to keep German troops awake and exhausted through the night. This constant pressure wore down enemy formations before major offensives even began. Mobility, again, played a role. Trucks and half-tracks gave artillery the flexibility to move with lightning speed, displacing batteries before counterfire could reach them. In contrast, horse-drawn German guns often lagged far behind, unable to adapt to the pace of modern mechanized warfare. But it wasn't just logistics, it was philosophy. American commanders had embraced the idea that firepower could substitute for manpower. General George Patton himself remarked that the poorer the infantry, the more artillery it needs, and the American infantry needs all it can get. While said half in jest, the truth was clear. Shells were cheaper than lives. If a town needed to be taken, artillery would flatten it block by block, clearing the way for infantry to move through rubble instead of resistance. This industrial approach to battle had its critics. Some argued it prolonged fighting by destroying infrastructure that advancing troops then had to navigate. But the results were undeniable. German positions that might have held for weeks against frontal infantry assaults crumbled in days under sustained bombardment. The war on the Western Front became less a clash of armies and more a test of systems. On one side, Germany, limited by resources, tradition, and shortages. On the other, the United States, wielding artillery as an industrial product, applied with precision and in overwhelming volume. It was here, in the ruined towns and shattered forests of France, that modern war revealed its true face, not as a duel of soldiers, but as a contest of factories, supply lines, and mathematics. And in that contest, Germany was hopelessly outmatched, redefining the battlefield. By 1944 and 1945, American artillery had transformed the very nature of combat in Western Europe. No longer was the battlefield defined by daring maneuvers or brilliant tactical gambits. Instead, it became a space dominated by mathematics, logistics, and overwhelming firepower. German commanders quickly realized they were fighting a different kind of war. Blitzkrieg, built on concentration of armor, rapid thrusts, and bold offensives, was impossible when any massing of forces could be annihilated within minutes by coordinated artillery fire. Tanks that once spearheaded lightning campaigns were forced into dispersion, moving under cover of night and hiding during the day. Infantry companies that might have gathered for counterattacks instead remained scattered, fearful that even a brief concentration would draw the attention of American observers. The battlefield became a grid of destruction, where any movement risked detection and annihilation. Fire direction centers acted almost like military computers, processing incoming reports, calculating firing solutions, and unleashing steel with astonishing speed. A German officer once described the experience as fighting against a factory, a relentless machine that produced destruction with clockwork precision. The consequences extended beyond tactics. Morale in the Wehrmacht steadily eroded. Soldiers reported feeling helpless, their courage undermined by the knowledge that no amount of skill or bravery could protect them from sudden simultaneous barrages. German POWs consistently admitted that American artillery was unlike anything they had faced on any other front. Even veteran divisions that had survived Russia and North Africa found themselves crumbling under its weight. This shift redefined victory itself. On the Eastern Front, battles often hinged on mass infantry assaults and long grinding clashes. On the Western Front, U.S. artillery made prolonged battles unnecessary. It was not heroism in the trenches, but coordination in the fire direction center, and the endless stream of shells from American factories that decided outcomes. The battlefield had become something new, a place where industrial power, scientific calculation, and organizational efficiency proved just as decisive as the courage of soldiers. For Germany, this was a war it could not win. The legacy of firepower. When the war ended, the lessons of American artillery echoed far beyond the hedgerows of Normandy and the forests of the Ardennes. What the United States had achieved was more than battlefield superiority. It was the creation of a new model of warfare, one that would shape conflicts for generations to come. The time-on-target technique became the standard for modern artillery operations. The idea that dozens of batteries could fire as one single weapon system was no longer a revolutionary concept, but a doctrine. Exercises after the war coordinated as many as 72 guns in brigade-level TOT missions, demonstrating just how far the technique could scale. The proximity fuse also left its mark, becoming a cornerstone of post-war artillery and air defense systems. What began as a secret weapon in 1944 evolved into a technological template for precision-guided munitions in the decades that followed. More broadly, the American approach to warfare, treating battle as an engineering problem, shaped the Cold War and beyond. From Korea to Vietnam, from the Gulf War to modern precision strikes, the philosophy remained: use overwhelming firepower, guided by science and logistics, to minimize risk to infantry and maximize destruction of the enemy. For Germany, the experience was sobering. Field Marshal Erich von Manstein himself acknowledged the unmatched power of U.S. artillery. He understood that what defeated German armies in the West was not simply more men or tanks, but a doctrine that turned industrial production into battlefield dominance. The legacy extended into psychology as well. The sound of sudden simultaneous barrages haunted survivors, a reminder that in modern war, death could arrive without warning, calculated down to the second. In many ways, that terrified German soldier crouching in a trench in 1944 was glimpsing the future, a future where technology, industry, and mathematics determined victory more than the clash of individual soldiers. The age of heroic charges and decisive duels was ending. The age of scientific war had begun. American artillery didn't just win battles, it redefined them. And in doing so, it set the stage for the American way of war that still echoes across the world today. Overwhelming, precise, and ultimately decisive.